Hello, and welcome to my invited poster presentation entitled Enhanced Student Learning Using Augmented and Virtual Reality in Chemistry Education at the 2021 CTSI Teaching and Learning Symposium. My name is Shadi Dalili, and I'm an Associate Professor teaching stream at the University of Toronto Scarborough at the Department of Physical and Environmental Sciences. Since 2018, I have collaborated with Dr. Maryam Abdinejad, my co-author and currently a postdoctoral fellow, to develop a very easy to use and comprehensive educational platform to help students visualize and understand molecular structure in three-dimensional space. Throughout my many years teaching the second-year Introductory Organic Chemistry course to hundreds of students per semester, I have found that one of the biggest challenges for students is the ability to visualize molecular structures in their true three-dimensional form in a two-dimensional space. Traditional visualization methods and techniques such as ball and stick molecular models have very limited capacity to enhance students' understanding of 3D structure and are cumbersome and time-consuming to use. Augmented reality is a technology that seamlessly merges virtual objects with real-world images. So we hope to facilitate students' understanding and ability to visualize these molecules in three-dimensional space by creating different augmented reality and three-dimensional animations to visualize these different molecular conformations and structures from different viewing angles and magnification levels. We achieved this first by building 3D interactive animations and augmented reality images of the different molecular structures and conformations, and then we, as the first group at the University of Toronto, developed an app called Archimede that allows the visualization of these 3D images in augmented reality space specifically for chemistry. So first, a series of tactile augmented reality markers, which are similar to QR codes and really can be any image, were created, and these can be read by the camera of a mobile device. And then our Archimede app recognizes the image and simulates the molecular structures in a screen-based 3D environment. In collaboration with MADLab and through funding provided by ITIF, we have recently successfully developed the Archimede app for both iOS and Android platforms, as well as a simple and low-cost markerless version of the Archimede app. So essentially, without the need of any QR codes or any external images, we can simply point the camera of a mobile device at any flat surface and visualize a 3D image and zoom in and rotate the molecule to be able to visualize it from different angles and from different viewpoints. We have evaluated students' perceptions and attitudes to using these animations in the augmented reality Archimede app to visualize molecular structures in 3D through various different questionnaires, surveys, and quizzes. And as you can see from the different charts and graphs provided on the poster itself, students overwhelmingly commented positively on using these different tools, and they said that the Archimede app has significantly improved their ability to visualize these molecules in three-dimensional space. We have published this work in the Journal of Science Education and Technology, and we also have a follow-up paper being published in the Journal of Chemical Education regarding the development of the markerless app. Generally, students believe that these resources were valuable as supplements to the textbooks, and therefore in our future work will be directed at the following areas. Firstly, we'd like to further develop the app to convert more 2D lecture note and textbook images into three-dimensional images and structures. Secondly, we'd like to further develop the app so that images from the lab manual can be converted into three-dimensional structures. And finally, we'd like to further develop the platform so that we can convert images which are hand-drawn or downloaded by students into 3D. Unfortunately, there was not enough time in this presentation for me to talk to you about another exciting aspect of our research, which is using virtual reality for different chemical reactions and transformations such as bond breakage and bond formation. However, our long-term future goal is to design interactive classrooms based on this type of technology such that wearable headsets and VR displays and sensors can be used for both instructors and students as shown and described in our actual poster. Thank you again for listening to my presentation about our augmented reality app Archimede, developed for the first time at the University of Toronto as an educational tool for chemistry students. And I would also like to thank CTSI for the invitation to present our work to you. I would be happy to answer any questions and provide access to the Archimede app if you are interested, and I can be reached at sh.dalili@utoronto.ca, which is also provided on the poster. Have a lovely day and stay safe.